We have seen how to find joint CDF from joint density. Now we plan to do the other way around. Now remember, if we have joint density, then definitely have joint CDF, because joint CDF always exists for any joint distribution. But given joint CDF, there is no guarantee that joint density must exist. So we have to be careful about that. But the basic idea is pretty simple. When you are given joint CDF, you have to differentiate. If it is a bivariate CDF, you have to differentiate with respect to both x and y. So we have to talk about mixed partials. Here is the result. If fxy is a joint CDF admitting a joint density, this means it is the joint CDF of a distribution for which a density exists, then you can find the density as, then this mixed partial will be a joint density. Of course, it does not matter which one you differentiate with respect to first, you will get the same answer. Well, now there is a little catch here. It is not that someone has given you just a joint CDF and you are finding joint density. Someone has given you a joint CDF and have also given you the condition that it allows and admits a joint density. So if someone just gives you a joint CDF and asks you to find a joint density if one exists, then how do you proceed? Well, you again have to find out this, and then you have to check whether iterated integral of this will really lead to that or no. Now there is another catch. That catch is, I said just partially differentiate. It may happen that for certain values of x and y, the partial derivatives do not exist. Then what do? Well, you just set the value of fxy equal to 0 at those troublesome points. In that case, if joint density exists, this will be a joint density, and if this does not work, then nothing else can. So if you are not told beforehand whether a joint density exists or not, you find this and you try out directly to see whether integrating this will give you back capital F or not. So let's take a look at an example. Suppose this is our joint CDF. This is the joint CDF that we had obtained in our last video. So there we know that it actually came from a joint density. So we know a joint density exists and we want to find it out. So what do we have to do? We have to find this mixed partial. We have to differentiate with respect to x and also with respect to y partially. Now observe that in any part where the formula does not involve both x and y, it must be 0, because when you differentiate this partially with respect to y, this will vanish. When you differentiate this partially with respect to x, it will vanish. So one of them is going to kill any part which does not have both x and y. So immediately I can say, when I want to compute little fxy, the density, that this will have 0, this will have 0, this will have 0. So the drama is concentrated only over this unit square. Now if I partially differentiate this with respect to y, what do I get? I get this. Now I partially differentiate this with respect to x, what do I get? I get 1, and indeed that was the joint density that we had started with when we arrived at this particular joint CDF. Here is a rather complicated looking bivariate CDF. I tell you that this corresponds to some joint density. You have to find out that joint density.